Welcome to the south destination of the three UGIs. We are in the south of Russia. Together we moved from subarctics, from tundra and forest tundra, through south and north taiga and broadleaf forest here to the dry steppe conditions. The weather is really hot. The temperature is about 35 to 40 degrees and soil temperature is also comparable. It's dry. The biomass is mainly grassy, so in these conditions we can observe formation of the most fertile Chernozomic soil. The abundance of biomass and high biodiversity and the domination of the root biomass over the above ground biomass creates the conditions for formation of the deep and rich in organic matter Chernozomic soils. In result, the region is historically dominated by agricultural activity. Less than 1% of the area are natural forests, whereas agriculture covers more than 70%. And therefore, soil resource and anthropogenic effect on soil resource is the hot topic for the region which we are going to observe.
Rostov-on-Don city is situated on several hills, and the top area of those hills is highly settled, but the slopes and the bottom not. That's because of engineered conditions, and you know exactly that these river valleys as well as ravines and gullies are very important in the city from a point of view of green infrastructure, green corridors.
The climate of the Western Pre-Caucasus, also called North Caucasus, is determined by the proximity of the Azov and Black Seas in the west and the high ridges of the Caucasus in the south. This territory is characterized by a continental climate, colder winters, a shorter vegetation period, and a shorter amount of the active temperature. The influence of dry air masses of the Caspian steppes causes a low annual rainfall of 400 or 500 millimeters.
For the Rostov region where we are, the zone type of vegetation is steppe. Under influence of the soil and climatic factors, the different types of steppes are formed. They are characterized by high species variety and dominance in vegetation recovery of perennial grasses, as evidenced by the predominance in grassy cover of dense cereals. Agricultural activity of man led to decrease of vegetation area. Nevertheless, when the agricultural activity at this area is finished, the recovery process of the steppe vegetation is occurred. It occupies many years and has series of steps when ruderal plant species are replaced by the native forms. This deposit that we can see is in the final stage of fescue virgin land. High part in the vegetation cover of other leading families of steppe flora are presented by dense cereals, fescue and feather grass. Besides it, the high part of plant recovery plays the families of cereal and bean. The presence of beets and rhizome cereals suggests that the recovery process of the steppe vegetation has not been completed yet. Aspect-forming species give the plant community a yellow color. The first tier, dominant steppe species, steppe motley grass species, meadow and ruderal meadow species, ruderal species.
A few words about zonal soils of our botanical garden and Rostov agglomeration generally. There are located here ordinary Chernozymes or haploid Chernozymes according WRB. Chernozymes always attracted the attention of soil scientists as an object of agricultural production. However, the development of urbanization processes make us to study Chernozymes in the context of their capacity to fulfill ecological, protective function under extremely high anthropogenic loads. And this territory of botanical garden and soils which are here can be used as reference or comparison standards for studying of anthropogenic soils.
Hello guys, welcome to Rostov Chernozem. Here is real Chernozem from Russian Federation. Let's go, let's to see what is the soil. Is it unique or not unique soil in Russia? Is it classic Chernozem or not? We will describe a little bit this soil. So, what about horizons? What about materials, texture, structure? We will see. We will start from topsoil horizon, humus horizon. So, you can see here very good structure and fine earth. Unfortunately, this profile is so dry, a little bit dry for us, but in next time, if you will see, if you will visit us in Rostov, you will see fresh profile. We can see here subangular blocky structure, little bit subangular blocky, and some details and some granular structure. This is clay loam, and here we can see a lot of medium and fine roots. We will take new fresh soil aggregate with good structure and some drops of hyaluronic acid, and you can see bubbles, the result of chemical reaction between calcium carbonates here. It's not lithogenic carbonates. Of course, parent material is loess-like material with smectides, but it's real product of biogeochemical weathering and soil formation, because these carbonates and the source of carbon dioxide is from air, and with rain is coming to this soil, and this here we have calcium from parent material and chemical reaction here into the soil, into fine earth, and in subsoil horizon with subangular blocky structure. On this zone we can see new forms of carbonates, of aggregates, is like mycelium, and this mycelium is have huge reaction, strong reaction, and you will see in the table the content of calcium carbonates here, pedogenetic carbonates. And here in the lower part of subsoil of medium B horizon with carbonates, we can see the products of segregation of carbonates, huge, small and medium conglomerates. You can see the very strong reaction, and in next time, in future, you can see this offline here in Rostov. Welcome.
After the description of the profile, soil samples will be collected from each horizon and sent to the laboratory for physical and chemical analysis. However, some basic information or preliminary data can be collected right here with the express methods of analysis. One of them is XRF analyzer. Normally it is used to analyze the bulk concentrations of heavy metals, and we implemented it in the industrial baron in subarctics. However, here we can also use it to analyze metals, and not only. For instance, calcium, which concentration here is very high, can be also detected with the analyzer. And now we can try to check the profile distribution. So we expect that the percentage of calcium will increase. So for the concentrations of the elements in the B horizon, we see that it's slightly, well, it's considerably different from what we see on the top. And as expected, calcium here is number 1. The concentration is 6.2 in comparison to 1.6 in the top. So the difference of the calcium carbonates is almost 4 times, and this generally confirms the idea of the vertical migration of the carbonate down the profile. So the final screen will be done for the subsoil, and we expect that calcium concentration probably would be even more high. And now we do the final screening of the BC horizon, and the results shows that calcium again is the element with the highest concentration, and the concentration is 10.25. This is 2 times higher than in the B horizon and almost 8-9 times higher than in the A horizon. So basically, with the in situ measurements right here, right now, we demonstrated that the carbonate distribution down the profile actually occurs, and kind of illustrated the results that likely will be further confirmed in the laboratory analysis. So this is the basic principle of the express methods of analysis, which we used before for the heavy metals, and here we demonstrated that it also works for the calcium carbonate. Carbon cycle, and especially carbon sequestration, is among the most important soil functions. And here in the Chernozomic region, in the steppe conditions, we can see this function with the highest level, let's say, because Chernozomic soils are the most fertile and have the richest carbon stocks in the world, and carbon sequestration here is going very intensively. At the same time, high microbiological activity results in intensive carbon emission, and besides, as it was mentioned, most of the soils here are disturbed in result of the agricultural activity, now also in result of the urban activity. So this carbon balance is not that stable, and to understand the carbon input and carbon output, to understand carbon stocks and fluxes, we do the continuous measurement of carbon stocks and of soil respiration. There are several ways to measure soil respiration. Most of them are based on the isolation of the part of the atmosphere and measuring change in the concentration of the CO2, and the idea is that the concentration is increasing, and the further measurement can be done at different level of instrumentations, let's say. The classical ones were based on the gas chromatography, which provides an information not only on CO2 but also on methane and N2O. However, the frequency is not that high, and that's why the fluxes are usually lower than actually. That's why the most efficient approach is measuring soil respiration with the infrared gas analyzers. There are lots of models of the infrared gas analyzers, and here in the South Experimental Station we make some experiments on their comparison and validation. We use 3 types of the gas analyzers. This one is the PPS gas analyzer EGM5, and there are also 2 other models, the LICOR LI120 and the AZ gas analyzer with some modifications. So the main idea is that dependent on the company and dependent on the, let's say, advantages, the costs of the measurements and the price of the instrumentation can be very different. And of course, looking for more points for higher frequency, we try to select the most cost-effective approach and to validate it with the more expensive approaches, so to show that the cost-effective approaches are also relevant. And here Lycor is the most expensive, then we have the PPS, and then we have the AZ, which is almost 10 times cheaper, so that allows multiple points of measurement. And what we are doing here now, we are measuring soil respiration with all three devices and then comparing. And in parallel, we measure soil temperature and soil respiration, soil temperature and soil moisture to explain the diurnal and seasonal dynamics in soil respiration. Okay, so the measurement has been started, and we place the chamber on soil. Since soil respiration includes the respiration of fruits and microbes, and does not include the respiration of the above ground biomass, the above ground biomass is removed. So basically we place it on the bare soil, we close the chamber, and we start checking the increase of the concentration. So we started from 400, and let's see what will happen here. It will take some time for the gas to go through the pipe to the cell where the analyzer actually is, and now here it is. So we start seeing the increase. We started from 400 and now it's 410, 411. Let's give it some time. So far we return to our previous measurements. 3 minutes passed and we fixed the increase. How much was an increase? So we started from more or less 400 and we ended to 572. This is 172 per 3 minutes. So this flux is quite high. It's way higher than those we saw in the northern conditions. And afterwards we will plot this the graph with the increasing concentration and estimate the flux. What is interesting is also what time to measure. Now it's around 12 p.m. Yeah, so it's midday. It's a little bit too hot to measure in steppe in these conditions. Normally in steppe the average emission can be measured earlier in the morning, let's say around 10 or so. And to verify this period we do the diurnal respiration. Okay, so we reached 500, we put a stop here, we stop record. Yep. Okay, so it's not recorded any longer, and we're almost done. The final thing that we can do is just to check the file. So this is the file, it is the txt file. We open it, there are so far just some numbers and commas and separators, but we will open it in the Excel file and then make all the calculations and analyze the flux.
Добрый день, друзья! Мы сейчас находимся на территории ботанического сада ЮГИ.
Welcome to the area of the Botanical Garden of South Federal University. This is one of the oldest botanical gardens at the south of Russia, founded in 1927. Since then the area was considerably reconstructed, lots of tree species were planted, since initially the area was dominated by the steppe and valley landscapes of the Timirnik River. For some period the area was used for mining the materials for building construction. However, in result, an interesting landscape and a combination of environmental conditions allowed creating a nice collection of tree and shrub species. The total area of the botanical garden includes two parts. One part is the river valley, where we are now and where the soil construction experimental site is located, and the other one is the watershed. The watershed area is dominated by the ordinary carbonated chernozem.
где находятся основные коллекции фонда ботанического сада. Мы сейчас находимся на почвенном стационаре.
Now we are at the soil construction experimental site, where we work together with our colleagues from the Rostov-on-Don University within the Russian Science Foundation project. Within the project, 3 experimental stations to investigate soil constructions were created at different bioclimatic zones of the European territory of Russia. We use the similar approaches, and some of the constructions are similar between the experimental stations. However, mainly we try to focus on the substrates and constructions which are typical for the region. So here in Rostov-on-Don we focus on the materials and constructions which are used for green purposes in the south of Russia. First of all, these materials include topsoil of Chernozem, removed for the building construction purposes and relocated here, sands, losses, and other materials which allowed us to create different types of soil constructions to perform the ecological functions we are going to investigate. We do not investigate bare soils, we investigate soils which are covered by green lawns, and in result the ecosystem of the technosoil in green lawn and the ecological functions is the main research topic of the project. We characterize carbon balance of this lawn technosoil ecosystem with the stocks and with the fluxes. For the stocks, we measure soil carbon stocks. We collect samples twice a year, and we collect biomass by cutting weekly or bi-weekly, depending on how intensively grass is growing. And for the fluxes, we analyze soil respiration, which is the CO2 emission by microbes and by roots. And similarly to the steppe conditions, we use the infrared gas analyzer. And in parallel, we measure soil temperature and soil moisture. So let's check what do we have in terms of the soil temperature and soil moisture. For soil temperature, we had 27 degrees, which is comparable to what we had in the steppe. But for the soil moisture, we have 39. And if you remember, in the steppe conditions, it was just 10, 12. So basically, soil moisture is almost 4 times higher. And that's a critical condition, because with the similar amount of carbon and similar temperature, an additional soil moisture in all this dry climate can result in a very intensive emission, which we will double check. So we start recording the file, we close the chamber, and we will observe changes in the curve, which is actually the change in CO2 concentration. So we start from rather low values of 428, and let's see what will happen. Okay, so it starts growing, and it grows quite intensive. So that was the time period between the recording, and that's why it's parallel. So the concentration didn't change. This is the concentration in the air, and this is the flux. This is the CO2 which is upcoming from the soil, and you see that the curve is really, let's say the speed of CO2 increases really fast. It's faster than in the steppe condition. So basically we can say that in technosols, where the input of carbon is comparable or less than in the steppe, because the biomass here is lower and also the root biomass here is lower. However, the intensity of soil respiration is almost twice higher, so it increased more than 150 ppm just in 30 seconds, and I would expect that the flux could be around 2 milligrams of CO2 per square meter, or maybe higher. So basically, such an intensive respiration with the carbon stocks comparable or lower than in the steppes could indicate that these ecosystems, at least at this stage, yeah, they're just 1 year old, are non-sustainable in terms of the carbon balance. They are more likely carbon sources than carbon sinks.
For the registration soil temperature, we use automatic loggers for the temperature, and we place them on the row to the depths 0, 7 and 20 centimeters. And now we are downloading this data to the computer. For this we use such registrator and special soft. And there you can see on the screen the temperature at the depth 0 centimeters, and you can see that it depends on the time of the day, with the highest temperatures at the afternoon and the lowest temperatures at night. This is the data from the 1st of May to the 27th of June, and you can see that for this period we have the lowest temperature about +9 degrees Celsius, and the highest temperature about 34 degrees. And there is a dynamic for the day with the highest temperatures in the afternoon and the lowest temperature in the about 1 hour AM. And these loggers registered the data every 3 hours. And here you can see the data of the temperature at the high of 20 centimeters. There is a big difference between the temperatures at the top of the soil and in the depths at 20 centimeters.
Добрый день, мы с вами находимся.
Good afternoon. We are in the park named after famous Russian writer Nikolai Ostrovsky. There was a reconstruction and 2 previously existed parks were joined together. Now the total area of the park is about 30 hectares. The park is divided by a sports area that belongs to the Olympic Reserve School. This is one of the oldest parks in Rostov-on-Don. If we go into history, then initially it was park in the city of Nakhichevan-on-Don, not Rostov-on-Don. It was a different city, and the head of this city, Minas Balabanov, decided in 1888 that a nursery garden should be established here. Today, at least 70% of the park is covered by trees and shrubs. There are several thousands of trees, and the species composition has not changed much since the foundation. The plantings here are very harmonious, because small groups of some species are combined with small groups of other plant species. It is done to prevent spread of diseases from tree to tree. At one place we have a group of pines, then a group of ash trees, then elms, etc. There is a special microclimate here. Humidity is different than in the city and the wind is not so strong. Therefore, these comfortable conditions help birds to settle here. There are over 50 bird species in the park. They can be seen from the end of March till June or even longer. We also try to preserve the soil cover. We have lawns almost everywhere and we take care that the wind does not blow away our park. Lawn cover preserves soil from wind erosion. The park gains a leading position among other parks in Rostov-on-Don. A large team of greenkeepers and gardeners work here, because 30 hectares is quite a large area that requires permanent efforts to maintain it. Talking about an open part of the park, we can see it. This is a glade, and actually it is the only one open space. Due to the fact that the park is very old, the distance between trees is 5-6 meters maximum. And if we use modern aerial photography, we will see that the park is almost a solid green cover, and it is like such a big lung of the city. The management of the park is developing an ecological direction in Rostov-on-Don, and we can say that our park is a testing polygon for various monitoring techniques and multidisciplinary platform for environmental research and education.